Hey guys, so today I wanted to start taking you through OpenNest, which is a free free nesting plugin for Grasshopper. So you give it a whole bunch of geometry and you tell it sheet size, and then it does its best to arrange it efficiently on that sheet. So what we're going to do is I've taken the carcus sections, the 3D ones I've generated in the last tutorial, and then we're gonna unroll it all and get it ready to put into OpenNest, and we'll see how we go. So the first thing that I want to do is just clean this geometry up a little bit, because I just want to merge mainly all these back faces, all the back faces of each thing. Reason being is because you'll see that little bit of a difference there. Oh, there's a slight difference. I want to use the largest face, which is the bottom face of each one, to orient from. And I want to be able to find that very easily just by taking the area of all the faces and then sorting it. Sorting that area, sorting these faces, reversing that sort. God, the amount of times I've done that workflow there. Did the wrong thing there. Do that every time as well. Cool. So there's the largest face in each one. That looks about right. So let's just evaluate that surface. Do we want to do that, or can we just... Oh yeah, because I need the frame eventually as well. I could have used that point there. Doesn't matter. Boom, boom. Parametricize that one. And what I'm going to do is, so I've taken all these breps. I've essentially exploded them all, and then I've resorted the faces according to how big they are, right? And then what's sitting here is the faces in order of area. So if I go and join them up again as well, this could come in handy later on down the track. So they're essentially the same. Yeah, they're put together again, but they're the topology is what it's called, of which face comes first has been changed. So we'll just sort of keep that one under our hats. And then what we're going to do now is we want to essentially take each one of these, because it's currently existing in 3D, and just flip it so that it sits flat on the ground. And OpenNest has a pack objects in a row function or component that does that pretty nicely, actually. I just want to... Let's have a look. I think I just need to... flip plane. I use this component a lot. Thank you, Michael Pryor. And I just want to flip it in the Z, which is the default. Anyway, so what does pack objects want? It wants geometry, which is these guys. It wants plane, cool, which is this one here. And I know from experience that it likes it to be flattened for whatever reason. So we'll plug that in, and there we go. Because I need to orient that, I flip that plane. What this will do is put them all on the ground and essentially put a bounding box around them. Put the next one there, like right next to it, to show you. I can do this, and that essentially moves each one across a little bit just for visualization purposes. Cool. So what we're going to do now is we're going to debrep them from here, and then what I want to do is I'm going to grab that one. I'm going to turn it into a curve now. So then essentially we've got like an outline of each geometry, and this is going to be unique to the way your geometry is made, but like that one, which is very good. And we've got, and then just turn it into curves very quickly. So we're nearly ready to put this into openness. But there's one more tip that I'm going to give you, and I learned it from experience. Is that the way the openness works is like any other like many algorithms. It operates at a certain speed, and if you want to minimize that speed because you have a lot of geometry, you want to keep your geometry as lean as possible. So as we touched on before, these are all polylines, which is great, but these are NURBS curves, and openness doesn't like NURBS curves because it has to calculate the positions of a whole bunch of geometry. It kind of shits the bed when it comes to dealing with a lot of NURBS geometry. And just while I explain this, I'm going to set up my sheet size of 1200 by 2400 by 1200, and there it is. So what we're going to do is to convert to polyline. We're going to convert this to a polyline, and you see it, but like we kind of want to minimize. See how the original curve is like this, and then the polyline wants to shave a whole lot off it. What I'm going to do is put, I think, a minimum edge length of like, I'll go between like 10 and 500. I think I want about 30. Yeah, there you go. So it's kind of minimize that. Long story short is we've got a few more points, but that's fine. That's fine. Another thing, if you're dealing with 3D geometry, you could have just converted it to meshes and grabbed that, but I like to have full control over my workflows. Cool. So these curves are ready to go into openness, and we'll do that at the start of the next video. Thank you.